Hi dear children, welcome to today's class. Today we are going to discuss irrational numbers. Before that, we will just go through the rational numbers. What is rational numbers? A number A is rational if this A we can express it as P by Q, where P and Q are integers, P and Q are integers and Q not equal to 0. Okay, if you can express a number in the form P by Q, wherein P and Q are integers and Q not equal to 0, then we can say that that number is rational number. And then irrational number, if a number is not rational, then we will say that number is an irrational number. If this is a rational number, and if a number is not rational, that means that number is a irrational number. Okay, so irrational number means we cannot express it in the form P by Q. Okay, a rational number means, suppose C is said to be an irrational number, it means it cannot be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. Okay, now root P, where P is a prime number. P is prime, then root P, that is always an irrational number. If P is prime, then root P, that is always an irrational number. Example, root 2, root 3, root 5, root 7, etc. These are the some examples of irrational numbers. Now, we are going to discuss theorem. We have one theorem in this section. The theorem says that let P be a prime number. This P is a prime number if P divides a square. If P divides a square, then P divides A. Okay, if P divides A square, then that P divides A also, where A is a positive integer. Okay, this is our theorem. If P is a prime number and that P divides A square, then P divides A also. This theorem we will use to prove root 2, root 3, these numbers are irrational. Okay, we will use this theorem in the proof of irrational numbers. Okay, so first I am going to prove root 2 is irrational. We know that this root 2 is irrational. Here we are going to give proof for that. Okay, root 2 is irrational. This we need to prove. We will assume that root 2 is not irrational. Actually, we need to prove root 2 is irrational, but we will assume that root 2 is not irrational. Root 2 is not irrational. If it is not irrational, that means root 2 is rational. Okay, so we will assume that. Let us assume that root 2 is rational. Assume that root 2 is rational. What is the speciality of rational number? If a number is rational, then we can express it in the form P by Q. Okay, here root 2 is rational, so we can express this number in the form P by Q. So I'm going to write this root 2 as A by B. Okay, root 2 as A by B, where A and B are integers and B not equal to 0. A and B are integers and B not equal to 0. Okay, along with this, we will assume that this A and B have no common factor other than 1. Okay, thus A and B have no common factor other than 1. Okay, A and B have no common factor other than 1. Okay, so if A and B have no common factor other than 1, then we can say that the A and B are co-primes. Okay, A and B are co-primes. Okay, If A and B have no common factor other than 1, then we can say that A and B are co-primes. So what is our assumption? Root 2 is irrational and root 2 is equal to A by B, where A and B are integers, B not equal to 0, and A and B are co-primes. A and B are co-primes. Okay, this is our assumption. Now take this B into the side, then we will get root 2 into B is equal to A. Now square on both sides, then we will get 2B square is equal to A square, or we can write it as A square is equal to 2B square. A square is equal to 2B square. Here we expressed A square that as the product of 2 and B square. Okay, here A square that is the product of 2 and B square. Okay, if you can express a number as the product of 2 and some other number, then we can say that that number is divisible by 2, or 2 divides A square. Okay, just listen. 18 that we can express it as 2 into 9. Okay, no need to bother about the second number. Anyway, 18 is 2 into 9. Okay, this we can, from this we can say that 2 divides 18. Any problem? We can say that 2 divides 18. Same here also, in this, instead of this 18 we have A square. A square we expressed it as 2 into B square. Okay, 2 into B square. Similarly, here also we can say that 2 divides A square. Here also we can say that 2 divides A square. If you can express a number as the product of 2 and some other number, then we can say that that number is divisible by 2, or 2 divides that number. Okay, so from this step we can write 2 divides A square. And we discussed one theorem. What that theorem says? If P divides A square, then P divides A also. P divides A square, then P divides A also. Here this 2 is a prime number, so we can apply that theorem here. 2 divides A square. This implies 2 divides A also. 2 divides A also. Okay, by using that theorem, if P divides A square, then that P divides A also. P is a prime number. We know that 2 is a prime number. And we got 2 divides A square. That means 2 divides A also. Now, 18 is equal to 2 into 9. That we can, from this we can say that 2 divides 18. Or if 2 divides 18, then we can express this 18 as 2 into some number. Okay. 2 divides 18 means we can express that 18 as 2 into some number. Product of two numbers is the one number that should be 2. Okay. Here we got 2 divides A. Okay. 2 divides A we got. That means we can express that A as 2 into some number. 2 into some number. C is some integer. Okay. 2 into some number. So in this expression, this last one, put it as equation number 1. In that expression, just put the value of A. We will get 2B square is equal to 2C all square. This is equation number 1 implies. We have A square, that is become 2C square. That is 2B square is equal to 4C square. Right. From this we will get B square equal to 2C square. B square equal to 2C square. Okay, now just look at this. Here we got A square equal to 2B square. And what was our conclusion? If A square equal to 2B square, then 2 divides A square. Okay. Instead of that, here we got B square equal to 2C square. B square, here we expressed that as the product of 2 and the C square. Here we expressed that as the product of 2 and C square. Okay, which means 2 divides B square. 2 divides B square. And 2 is a prime number and it divides B square. Then by using that same theorem, we can say that 2 divides B also. 2 divides B also. Okay, now just look at these two conclusions. 2 divides B, 2 divides A. 2 divides B, 2 divides A. That means 2 is a factor of B and 2 is a factor of A. That is, 2 is a common factor for A and B. Okay, 2 is a factor of B and 2 is a factor of A. Okay, that two statements we can combine together and we can say that 2 is a factor of A and B. Is it possible? Is it possible 2 can be a factor of A and B? No, that is not possible, because what was our assumption about this A and B? There is no common factor for A and B other than 1. That was our assumption. There is no common factor for A and B other than 1. That was our assumption. But we got one conclusion, that is 2 is a common factor for A and B. It cannot happen. We got a wrong conclusion. Why we got a wrong conclusion? Why we got 2 divides A and B? We got this wrong conclusion only because of our wrong assumption. What was our assumption? We assumed root 2 is a rational number. That is not possible. If root 2 is a rational number, we got 2 wrong conclusions. So our assumption is wrong. Root 2 is not a rational number. Then what is this root 2? Root 2 is irrational. Okay, if root 2 is not rational number, if that assumption is not possible, which means root 2 is not a rational number, then what is this root 2? Root 2 is irrational. So we conclude that root 2 is irrational. Okay, so this is the proof. This is the proof for root 2 is irrational.